And as you can see, there are lots and lots of elements in this periodic table, but only a portion of them are important to life. So the most important elements for life can be remembered with the acronym SCHNOPSKA. It's a funny little acronym. And the acronym is made of the elements' periodic table abbreviations. So let's go through each of the abbreviations. First, we have carbon. Carbon is a very, very special element because each carbon atom can make up to about 4 bonds, which is a lot. This ability to make many bonds will be important when we start talking about macromolecules. Next, we have H for hydrogen, which is often bonded with carbon to make long chains important in macromolecules. Then we have nitrogen, which is an important constituent of proteins and DNA. Then we have O for oxygen, and that's an important so that we can breathe. Breathing oxygen allows us to make energy. We'll get to that during our cellular respiration unit. Next, phosphorus is literally the centerpiece for a functional group called the phosphate group. Functional groups are a group of atoms that are commonly bonded together and, when attached to another molecule, give it a specific property. Phosphate groups, or PO4, make up the backbone of DNA. Later in the lecture, I'll give you more examples of functional groups and how they affect molecules. Then, S for sulfur, that ends the list of the 6 most important elements for life. Together, they make the acronym SCHNOPS. 2 elements of lesser importance are potassium and calcium, which can be added to the acronym to make SCHNOPSKA. It's a little hard to say, but yeah. Potassium is K, and calcium is Ca. Next, let's talk about atomic bonds. One type of bond is called the ionic bond. This bond involves 2 ions. Ions are atoms that have a charge because of an unequal amount of electrons and protons. Recall that electrons have a negative charge and protons have a positive charge. Now, let's look at this sodium atom over here. Recall that sodium's atomic number is 11, so it has 11 protons and 11 electrons when it is not an ion. Now, all atoms want a full or empty valence shell, which is the outside shell. As you can see, sodium has 1 valence electron and would like to very much get rid of it. Chlorine, on the other hand, has an atomic number of 17, meaning 17 protons and 17 electrons in a non-ionic state. Chlorine needs 1 electron to fill its valence shell, so it would love to accept an electron from another atom. Thus, chlorine and sodium are perfect matches for each other. Sodium gives up its valence electron to fill chlorine's valence shell. Now, sodium has 1 less electron than proton and becomes a positively charged ion, called a cation. Chlorine now has 1 more electron than proton and becomes negatively charged ion, called an anion. Because chlorine and sodium are oppositely charged, the opposite charges attract. The 2 atoms form an ionic bond with each other. The resulting molecule is called sodium chloride, or table salt. Ionic bonds like this are of medium strength. The strongest atomic bonds are called covalent bonds. In these bonds, pairs of atoms share their valence electrons. Take, for example, water. On the right here, you can see water is H2O, which is 1 big oxygen atom bonded to 2 smaller hydrogen atoms. Each of the hydrogen atoms has 1 electron, and the oxygen atom has 6 electrons in its valence shell. And each pair of oxygen and hydrogen are sharing each of the electrons. So these electrons are going in both the orbitals of the hydrogen and the oxygen. The weakest bond is the hydrogen bond. To explore a little bit more about the hydrogen bond, we need to take an even closer look at water. The oxygen atom in water has two covalent bonds with each of its hydrogen atoms. That means that each atom is sharing their electrons. But they aren't sharing equally. The mass of the oxygen atom is a lot more than the mass of the hydrogen atom. So, the electrons are slightly more attracted to the oxygen atom than they are to the hydrogen atoms. This means that oxygen has a slightly negative charge and hydrogen has a slightly positive charge. The result is that water is a polar molecule. Polar molecules are molecules with a positively charged end and a negatively charged end. This is a very important property of water, which gives it many other special properties that we'll talk about very soon. But back to the hydrogen bond. The oxygen and hydrogen atoms are oppositely charged, but each molecule has a slight charge only. So there is a weak attraction between the hydrogen and oxygen atoms. Hydrogen bonds, in general, are weak attractions between a hydrogen atom and a slightly electronegative atom.